Hello and welcome back. We have left off in the topic of modules and we are in exercises modules 1. And let's look into it. So we don't have an assessment. We have here a command: don't let anybody outside of this module see this. So this has to remain a private function. But maybe first, what's actually a module? A module lets you basically put together code that is related. So you have here something, for example, sausage factory, and you have functions that are related to the logic of the code. So this code is related to each other and you can basically collect it together. You can put in modules your functions and complex types like enums and structs and really anything you want. And it's just to make the code more readable and clean, so you can basically collect it in one modules and you will have the same logic of the code over here. So, and also you can then access it from, for example, another program. If you make, for example, a library and you have code logic that is in a module, you can then externally access the module like this, for example, and you can access the functions inside the modules like this. As you can see here in main, we access sausage factory and we access the function makes sausage. Now, as you can see in this module, we have two functions and this should remain private. So all this does is it will return a string ginger, and that's basically it. And the second one, makes sausage, it will first call this function, and that's no problem because this function is in the same scope as this function. Both are in the module's scope. And then all it does, it will print sausage, a string slice sausage, and that's basically it. So what's the problem? Here it says function make sausage is private. So this is a private function and we cannot call this function from main. This is another scope. We cannot call this function like that. And all we really have to do is just make this public. And now, as you can see, output is sausage, like we expected, because this main function calls this function, and then it will just print out this line. And that's basically it. Now you might ask why on line 6 we don't have to make this public. We actually can, and it will be the same really, but we don't have to because these two are in the same scope. So if they are on the same level, let's say, you can access it. And also children of a module can access what's outside, but from the outside you cannot access what's in the inside. So here we can without problem access sausage factory, even though this module is not marked as public, because siblings main and sausage factory are in fact siblings. You can access it without problem. That's why. But as you've seen, this is a children of sausage factory, and the main function could not access this function because it's a child of this module, and we had to make it explicitly public. That is why you can only access it from the inside out, but from the outside in you won't access it. So I hope this is clear. And modules, let's see, modules 2. Now we have here to fill out something. So you can bring module paths into scopes and provide new names for them with the use and as keywords. Fix these use statements to make the code compile. And here again we have a module, delicious snacks, and as you can see in here we have two other modules, so we can actually nest modules. So these two are siblings, and these two are also children of this module, delicious snacks. But let's start from the beginning. So here we have use statements, and what use statements are basically is, like for example in JavaScript, the import function. So you will basically use this. Self is always referring to the parent module. So instead of self, you could write here delicious snacks. It's both the same. Then we access fruits and then peer. So we access fruits over here and then we access peer. And as you can see, we have here as, and here we can give this peer an alias. And what an alias is, basically, you can give it another name. So instead of accessing it like that, you can give it an other name. And on this line too. And as you can see in the main function, we have a print line statement, favorite snacks, and it prints out these two values. So all we really have to do is to make, as you can see, delicious snacks fruit and delicious snacks veggie. So all we really have to do is just make this one fruit and this one veggie. So basically, when you call fruit, this is what will be accessed. The same thing over here. If you call veggie, this is what will be accessed. Now another thing, we have to make this public, and this is called re-exporting. So we re-export this. So in the main function, as you can see, we don't have to access it like delicious snacks, fruits, pear, or delicious snacks, veggies, cucumber. We can just use this alias and we don't have to write the whole path. I will show you in a moment what it would look like if we didn't re-export that one, but let's see if it's actually compiling. And of course I forgot the semicolon. So in use statements you always have to append a semicolon like that. And as you can see, the code is compiling favorite snacks, pear and cucumber. And that's actually the print line statement over here, favorite snacks, pear and cucumber. Now, as you saw, we made this re-exporting. So actually, if you don't re-export these use statements, you have to export it yourselves, or you have to access it from over here. So if I copy that, I will go over here and print it, or I will copy it into here. As you can see, we first have to actually write here delicious snacks, because we are accessing it from outside, we cannot use self. And then what we basically need to do is we can then delete that actually. Let me do it like that. And it should actually compile. It's not compiling. Private module. All right. And of course, as we are accessing these from outside, we have also to make that public. And also over here. And it's compiling, as you can see. So as you might have saw, this is a lot of work and it's not really necessary. So you can put use statements in the main or in another program if you would use a library, but it's not really important. So I will undo this, and as you can see, all of that was not even important. If we save again, it is compiling. So re-exporting really makes your task a lot easier, as you can just access the things even with an alias, and you don't have to basically import it again and again. So we are already in the last one, modules 3. You can use the use keyword to bring module paths from modules from anywhere, and especially from the Rust standard library, into your scope. Bring system time and Unix epoch from the standard time module. Bonus style points if you can do it with one line. So of course we want the bonus points, so we will do what is expected. And as you can see, to complete this use statement, as you can see, we have to complete that one so we can actually use the variables over here. Here in main we have a match pattern, and as you can see, we use something from system time. So this is actually a module. We use system time, the function now, and duration since Unix epoch. So maybe a little history. Unix epoch actually refers to this date, and this is when the Unix developers made actually this time stuff, you know, and this will always be this date. So an Unix epoch will start on this date, and basically all servers and all computers around the world use this Unix epoch. So as you can see, if it's okay, we will get n, and then we will print out the seconds that have passed since this date. And if we get an error, the program will panic. System time before Unix epoch. Right, and this is basically a result, but we will get into that later. So all we really have to do, because the description here is really good, we have to import from the standard library time, and we have to import two things, system time and Unix epoch. So you can actually write it like that, and then copy that and do it like this, Unix epoch, excuse me, Unix epoch, and it should actually compile. And as you can see, since the Unix epoch of this date, this much seconds have passed. But as you can see, bonus style points if you can do it with one line. So we won't actually do it like that. What you also can do is just put it like that. We will import system time and then Unix epoch like that. So we imported it in one line. It looks a lot cleaner, and as you can see, you will just surround it with curly braces like that, and you can import system time and Unix epoch from the time module. As you can see, it's compiling, so everything is fine. And we have reached the end. We will continue next time with hash maps. See you then.